Filter Design and Analysis Tool. The Filter Design and Analysis tool is a powerful user interface for describing and analyzing digital filters. It supports both FIR as well as IIR filter design. FDA tool enables to quickly design the digital filter either by setting filter performance specifications or by directly specifying filter coefficients. To start with Filter Design and Analysis tool, type FDA tool on the command window. The Filter Design and Analysis tool opens. The FDA tool supports several filter types: low pass, high pass, band stop, along with that special filters like differentiator, Hilbert transform and so on. Let us design a band pass filter. Once the filter type is decided, we need to go for selecting the design method. You can either select FIR or IIR technique to design the filter. Let us first opt the FIR window technique to design the bandpass filter. The remaining portion of the FDA tool is for filter specification. Filter specification supports filter order, frequency specifications and magnitude specifications. These filter specifications vary as per the type of filter and the filter method. Let us first understand filter order. Filter order has two options. Either you specify the order or choose the minimum order. The minimum order is decided by the design method we select. Let us opt for minimum order for our example. Next is the type of window. The windows supported are Hamming, Hanning, Kaiser, Blackman, Bartlett and so on. Let us go for Kaiser window. The display region of the FDA tool helps us to understand frequency specifications. The units or frequency specification can be set to either hertz, kilohertz, megahertz, gigahertz or a normalized frequency. Let us opt for units of hertz for this example. Sampling frequency is denoted as Fs, f-stop 1, f-pass 1, f-pass 2 and f-stop 2 all together are the specifications for the band pass filter. Let us understand these specifications from the display region. F-stop 1 is the lower edge stop band frequency, f-pass 1, f-pass 2 is the pass band edge frequencies, f-stop 2 is the upper stop band edge frequency. For our example, let us select sampling frequency as 2000. Let us set the f-stop 1, that is the upper stop band edge frequency, as 200 Hz. The pass band edge frequency, let it begin it at 3000 Hz. The upper pass band edge frequency, let that be at 700 Hz and let the lower stop band edge frequency have a value of 800 Hz. Let us now move on to magnitude specifications. The magnitude specification for the frequency response characteristic can be either set to either dB or a linear scale. Let us offer a dB scale. A stop 1, A pass, A stop 2 are the magnitude specifications. A stop 1, A stop 2 are the upper and lower stop band ripples, whereas A pass is the pass band edge ripples. Let us set the pass band edge ripple to its minimum, suppose 0.1 dB, and A stop 1 and A stop 2, that is the stop band attenuation, to each 75 dB. Here we complete with the entire filter specifications. Once the filter specifications are complete, click on the design filter to get the desired filter coefficients. The entire bandpass filter design for the specifications is seen in the display region. You can view this display region on a separate window by clicking on the Full View Analysis button. The entire response appears on a separate window. So you can understand here the pass band starts from 300 to 700 Hz, whereas the lower stop band is 200 to 300 Hz and the upper stop band is from 700 to 800 Hz. So this is the characteristic of a band pass filter. Whereas the stop band attenuation we had set was closer to 75 dB. So you can see here the attenuation in the pass band starts from 75 dB. Along with the magnitude response, FDA tool also supports the phase response. So click on the phase response button to get the phase response. To understand better, FDA tool supports magnitude and phase response plot, both of them together in a single plot. This can be viewed by clicking on the magnitude and phase response button. So you observe that the magnitude and the phase response both appear together. This helps us to understand magnitude and phase response better. So you can see here the phase response is entirely linear over the entire pass band of the band pass filter. This is so because the filter we have designed is an FIR filter that supports linear phase characteristics. Let us now look at the impulse response coefficients of the filter we designed. So this is the impulse response plot, and the FDA tool also helps you to give the list of the filter coefficients. So here are the entire numerator coefficients for the FIR filter we just designed. You can fetch this filter coefficients on the workspace window. To do this, click on the file option and open the export option. The export dialog box opens. Select wherein you need to fetch the coefficients, that is the workspace. What you need to export are the coefficients. Here is where you enter the name of the variable that will be assigned the variables, the coefficients to. Let us retain the variable name as num and click OK. So by this we have exported the entire filter coefficients to the workspace window. To view that, we will minimize the filter design tool, and here in the workspace you can view the num variable has appeared, which has the entire filter coefficients. We can view this by typing the variable name in the command window, num. So here you can see these are the values of the coefficients that we just have designed using the FDA tool. Now these coefficients can be used directly for designing any application. You can even save the entire FDA session by clicking on the Save Session button. Give a name to the file, suppose we write it as test FIR, and click Save. Have a note, the file is by default saved with a .fda extension. So you can save this file and Anytime later, open the file to retain your design specifications. So the file name is testfir.fda, saved in the work directory of Matlab. So this was designing FIR filter. On the same lines, you can now opt for IIR filter. So click on the IIR radio button and you can view the type of FIR supports: Butterworth, a Chebyshev type 2, elliptic are all the IIR filter types supported by FDA tool. Let us go for Chebyshev type 1. Let us retain the same bandpass filter and let us maintain the same specifications we had used earlier. With this, we will click on design filter and obtain the IIR Chebyshev type 1 bandpass filter. So this is the magnitude response of the plot. Let us view it on a separate window. Let us view the magnitude and phase response together. So what you observe in the pass band, the phase response is not that linear the way we obtain for FIR. These are the impulse response coefficients. We have both numerator and denominator coefficients put together in a matrix. Similarly, you can export these coefficients to the workspace and use the coefficients later for any application.